Okay, so far we've done pages 1 through 4 of the study guide, and today I'd like you guys to finish pages 5 and 6. So I'm going to go through these pretty quickly just to keep the video relatively short, so make sure that you do pause throughout so that you are able to listen, so that you are able to get down all the notes that you need to. All right, so this is a problem that some of you struggled with on a lesson in chapter 4, so I'm going to go over it here. It all has to do with slope, okay? So it says, examine the graph at the right, which displays 3 tile patterns. What do you know about figure 0 for each of the 3 patterns? Well, I see here that on the x-axis, that is our figure number. Figure 0 would be right here along the y-axis. This is what figure 0 would be because 0 is right there, okay, at this point here. So, pattern A, it looks like pattern A has 0 tiles. So A, 0 tiles in figure 0. Pattern B, look at B here, has 30 tiles in figure 0. And C also has 0 tiles, just like A. Okay, erase some of that. All right, so that's that one. Which pattern changes most quickly? How quickly does it change? That's basically asking which one has a greater rate of change, which is the slope. So if you want to find slope, you have to find 2 points on a line. So for line A, if you look at this, it's the least steep one. C definitely changes at a faster rate than A, so I don't even need to find A's slope. And if you look, we don't really have any exact lattice points besides the 0, 0. Other than that, like along here, I don't really know where those points are. Even where it crosses B, that might be 3.5, it might be 3.6, I don't know. So we could not accurately find the slope of A, but we can for B and C. So for B, the slope is going to be rise over run. Okay, so I see here that I have a point here and a point right here, which it tells me it's exactly at the 20. And then if you go straight down from here, that's at 2. I don't know why it's not letting me line it up. There we go. It's at 2, 20. Okay, so when doing this, I have this rise. You can see that B is a negative slope because it is going down. So I know it's going to be negative. And I go down for my rise. That's a change of 10 because I'm going from 30 to 20. So that's a change of 10 for my rise. And then my run going to the right, this is the run, from 0 to 2, that's a change of 2. Okay, so negative 10 over 2, which equals negative 5. So that is the slope for pattern B. Now we can do the same thing for C. Okay, same idea. For pattern C, again, slope is rise over run. So if we have a lattice point at 0, 0 for C, and right here at 220, I can draw a slope triangle where this is my rise, and they share the same run. Okay, in this case, my rise goes from 0 to 20. So my rise is 20, and my run is 2. So for pattern C, 20 divided by 2 is 10. So the pattern that's changing most quickly, even though this is a negative, that doesn't matter. If it was a negative 15, then that would be a steeper line than C, so then it would change more quickly than C does. But in this case, it's definitely pattern C that changes most quickly. It has the steeper slope. Steeper slope. Okay. It says here, which figure number has the same number of tiles in patterns? Oh, it's way over here, my bad. Patterns B and C. Explain how you know. So we see here there's an intersection for B and C, and that's figure 2 with 20 tiles. So we'll put figure 2, 20 tiles, lines B and C intersect at the point 2, 20, where 2 is the figure number and 20 is the number of tiles. So that's why we know in figure 2 they both have 20 tiles. Okay, so now it says write a rule for pattern B. So pattern B is this line here. We know its starting point is 30 and its slope was -5. Okay, so M is your slope and B is the starting point plus 30. And we took those notes up above as well, so you should have them from a previous page. Okay, so this would be the rule. Y equals -5x plus 30. Okay. I'm going to go ahead and copy this right here. Actually, that one's a little bit different. We'll do this one. Okay, so what is the rule of the graph? The rule is always y equals mx plus b. So we need to find what this particular rule is. So I'm going to zoom in on this graph here. So I see that my y-intercept when x equals 0 is at -2. So now that one's at -2. And now to find my slope, I'm going to replace growth with slope, because in this case, we're going to have to use rise over run. So M is rise over run. And you have to use, you have to use lattice points here. Okay, I see several of them marked for us. You see all these little black dots? Those are lattice points. So it does not matter which two you use. Let's say I didn't see this one, just say, and I went up a little bit higher. Okay, so that means my rise is 4, my run is 2. So my rise is 4, my run is 2. 4 divided by 2 is 2. And you would have gotten that if you did like from here to there. The rise would be 2, the run would be 1. 2 over 1 equals 2. So they're the same slope, right? No matter which 2 points you pick, they should be the exact same slope. So our slope here is 2, positive 2, because it's going up from left to right, so it is positive. Y equals 2x minus 2. Pull that a little bit closer here. There we go. Okay, so the rule for this one is y equals 2x minus 2. Make sure that you are pausing the video, because as soon as I'm done, I'm going to move on to the next problem. All right. The relationship between the average rating for a hotel in a particular city and the average daily price of a room at the hotel can be modeled by the equation y equals 75x plus 40, where x is the average rating of the hotel from 0 to 5 stars, and y is the average room price in dollars. So how much should a tourist expect the average price of a room to be for a 3-star hotel in the city? So 3 stars, that means I'm dealing with my x. Okay. So instead of x here, I'm going to put a 3, because it said where x is the average number or the average rating of the hotel from 0 to 5 stars. So here we have y equals 75 times 3 plus 40, and this will give us the average room price in dollars. I'm so sorry, I don't know what's wrong with my voice. I sound like I'm in a muffled microphone or something. So y equals, so 75 times 3, 225 plus 40. You should expect to pay $265 for a 3-star hotel in this city. Okay, a supermarket has found that the relationship between a day's high temperature and the amount of money taken in on that day from frozen yogurt sales can be modeled by the equation y equals 5x plus 153, where x is the high temperature in degrees Fahrenheit. So x is the temperature, the highest temperature it reaches that day. And y is the amount taken in from frozen yogurt sales. So you would think like whenever it gets hotter, more people would buy frozen yogurt because they're hot, they want to cool down. If it's colder, not as many people want a frozen snack, right? Like frozen yogurt. So how much were the frozen yogurt sales when the temperature was 80 degrees? So the temperature here is 80 degrees. And we want to see how that affects the frozen yogurt sales. So y equals 5 times 80 plus 153. 5 times 80 is 400. So they sold $553 worth of yogurt on a day that was 80 degrees. Okay, or had a high of 80 degrees. All right. So here I will do 2 different ways to solving these. The first step for these is the exact same. So you have to first distribute, okay? So this would become 6x minus 3, because you multiply 3 times 2x, 3 times -1, plus 7 equals -44. So now from here, it's going to be the exact same step. So I'm going to take a copy of this. Copy, paste. All right. So there's 2 different ways that you could solve this problem. The typical way, combining like terms, -3 plus 7 is +4. And then we still have that 6x plus 4 equals -44. Now you can subtract 4 from both sides. Again, I'm going super fast, so I hope that you've tried this before watching this. Okay, equals -48. Divide both sides by 6 to undo the multiplication of 6 times x. X equals -8. Okay. And then there's the other thing where you can move all terms to one side. So I see that I only have 6x on the left. So if I want to move these terms over, this becomes a +3, and then this one here becomes a -7. You have to change the sign if you do that. So on this side, I'm left with 6x, and over here, -44 still. Because I did not move those, so I'm not changing those signs. They're still the same. So now here I have 6x, 3 minus 7 is -4, minus 44 is -48. And you could always put this into your calculator too, right? So now I can divide both sides by 6, x equals -8. So you'll get the same answer. Okay. So now same thing here, the first thing you always have to do is distribute anything that is in the parentheses, okay? So 6 times 2x is 12x, and 6 times -5 is -30. Negative times x is -x. Negative times +4 is -4. Let me just move all this over real quick. Let's see if I undo all that. If it'll let me still paste. Yep, cool. All right. So now I'll do the 2 different methods. The first method, I'm just going to move them. There's no like terms to combine on either side. So I'm going to add x to both sides. Get 13x minus 30. 30 equals -4. Now I can add 30 to both sides. So I'm going to get 13x. -4 plus 30 is the same as 30 minus 4 is 26. Divide both sides by 13. X equals 2. Okay. Now this one I'm going to do the switch method. So I'm going to just say I want all of the x's to come over here. So that one will stay. But this x is going to change to a plus x instead of a minus x. So to move it across the line, you must do the opposite. This one, I'm going to keep the -4 there. But for this -30, I'm going to move it over here. It needs to become a +30 if I move it across that line. Okay? So now I can combine like terms. 12x plus 13, or plus x is 13x. -4 plus 30 is 26. Now I divide both sides by 13. X equals 2. Okay? Now these, it says solve for the indicated variable. So make sure you pause if you need to go over number 17 again, because I'm going to slide down to number 18. So it says solve for the indicated variable. The first one is solve for y. So I'm going to just draw a line. We're just moving terms here. So I need to get the y by itself. So I'm going to move away this 2x. So now that leaves me with 5y equals, you can either put 10 minus 2x or -2x plus 10. Doesn't matter either way. And now I got to divide everything by 5 to get that y by itself. So now I'm left with y equals -2/5 x plus 10 divided by 5 is 2. So that would be your final answer there. Now this one says solve for x, so I'm going to get the x by itself. The first thing I have to do is distribute the 3. 3 times x is 3x, 3 times 2 is 6. So I need to move everything away from the x, is what it means to say solve for x. So I'm going to subtract this 6 from both sides. So I'm left with 3x equals y minus 12. -6 minus 6 is 12. And then here I need to divide by 3 to get the x by itself. So these, like, I'm not going to get one single number. It's just asking me to move terms around. So y divided by 3, you could leave it like that, or you could write it as 1/3 y. -12 divided by 3 is -4. Okay. Sorry guys, I'm going pretty fast because I'm almost out of time and I need to go to work. So these are the last two. It says for each pair of lines below, solve the system first by graphing, then algebraically using the equal values method. So this is something a little bit new. So I'm going to graph them first. Oops. I'm going to graph them first. So this one has a slope of 7, which to write it as rise over run, it would be 7/1. And the y-intercept is -5. So at -5 over here, I'm going to put that point. Okay. And then my rise is 7, so I'm going to go up 7 and to the right 1. Up 7 and to the right 1. So there is my line. Okay. And that's the first one. All right. I'm going to erase those little ones. Okay. So the other one here, y equals -2x plus 13. So that means that my slope is -2, and we can put it over 1. So it's going to be going downward. And my y-intercept is 13. Oh, darn it. I totally forgot to give you 13 on this graph. So we'll have to work on that a little bit. This is the y-intercept. So I'm going to assume it's going to be 1, 11, 12, 13. Okay, and this isn't going to be perfect. But what we're going to do is we're going to use that to draw a slope triangle. So I'm going to go down 2 over 1, down 2 over 1, down 2 over 1. And I don't even need to plot that 13. I can just use that to show me, okay, now I got to go down 2 over 1 over and over again to get a point on this graph. Okay. So if you guys see here, I'm going to erase all these little things there. I'm even going to erase that because that's fine. We intersect at this point. So that is our solution of this system. Between these two lines, they both share the point 2, 9. Okay? Now, equal values method, this is how you do it. If these are both equal to y, we can set this part and this part equal to each other. So 7x minus 5 equals -2x plus 13. And now we can solve for x. So the first thing I'll do, I'm going to do plus 2x, get 9x minus 5 equals 13. Add 5, we get 9x equals 18. Divide both sides by 9, x equals 2. So I know for my solution, the first point, or the first part of my coordinate, x comma y, is 2. And that's the same thing over here on my graph. So now, to do it algebraically, you just take one of the lines. You could do both if you want. But we're going to replace the x with that 2. So it'll be 7 times 2 minus 5. 14 minus 5 is 9. So that is how you could do it algebraically. You first solve for x, and then you solve for y, because this is y here. Okay? Now, I recommend you guys try this one on your own for part B, but I'll do it really quickly. So again, here I have this line here, y equals 3x minus 1. So that means that my slope is 3 over 1, and my y-intercept is negative 1. So I'm going to go and plot the negative 1 first, and my rise is 3, my run is 1, rise 3, run 1, and that's where I'm putting the point, rise 3, run 1. So now that helps me, I can even go backwards if I wanted to draw my line. And you guys could definitely use a ruler, right? Okay. Oopsie, I did not mean to erase the points. Okay. All right. So that's the green line. Now let's go ahead and do this blue line. So the 3 is the slope, and it's the same as the other one, 3 over 1. 2 is the y-intercept. So I'm going to first plot it at positive 2, go up 3 over 1, up 3 over 1, and now I got to go backwards a little bit. Interesting. It does not look like these, whoops, it does not look like these lines are going to intersect. Why wouldn't they intersect? They have the exact same slope. Same slope, the lines are parallel, which means they will never intersect. So, no solution. And we'll go ahead and leave it at that because I want to get this uploaded to YouTube. Have a great day, guys.